This video is all about completing the square. In the first part, we're going to talk about what that means. In the second part, we're going to talk about how to do it. And in the third part, we're going to see why we would want to do it and how we can use it. So completing the square turns an imperfect square into an adaptation of a perfect square. So first thing I need to do is explain what I mean by a perfect square and an imperfect square. A perfect square is just another name for a square number. So 9 is a perfect square because I can write it as 3 squared. 36 is a perfect square because I can write it as 6 squared. Anything that is not a square number is an imperfect square. So for example, 10 is an imperfect square. But I can turn 10 into an adaptation of a perfect square because I can think of 10 as being a perfect square plus 1. 32, that is an imperfect square. But I can turn that imperfect square into an adaptation of a perfect square. I can take the perfect square of 36 and then subtract 4. So that's explaining perfect squares and imperfect squares and the process of turning an imperfect square into an adaptation of a perfect square numerically. Now let's have a quick look at that algebraically. So all of these are perfect squares. X plus 4, all squared, so that's a square number. X plus 7, all squared, so that's a square number, and so on. You need to be able to recognise these perfect squares in either their factorised form or their expanded form. So you need to be able to look at either of those and recognise them as being perfect squares. Again, all of these are perfect squares. X squared minus 12x plus 36 is a perfect square because I know I can write that as x minus 6 all squared. Now, like I say, it's really important you're able to recognise these things really quickly. So, what I want you to do now is pause the video and I want you to copy down these questions and expand these brackets really quickly. Each one should take literally 3 or 4 seconds. So press pause, answer these questions in your notes. Off you go. Okay, right now I'm going to show you the answers. So so can you mark those, please? Press pause, mark them. Make sure you all got them perfectly correct. And now I want you to go the opposite way. Again, press pause, copy down these questions, and each one I want you to show it's a perfect square by factorising it. Press pause, each question should take about 3 or 4 seconds, off you go. Okay, right now I'm going to show you the answers for those. And again, press pause, mark all of those, make sure you got all of those correct. Now that we've looked at perfect squares, let's see how we can adapt perfect squares to get imperfect squares. So x squared minus 12x plus 38, that is an imperfect square. I cannot write this as something squared. But I do recognise that this is very similar to this perfect square. In fact, I noticed that this is just this plus 2. So I could rewrite this as x minus 6 all squared plus 2. Just to re-emphasise this point, the minus 6 times x is minus 6x. Double it, we get minus 12x. The minus 6 squared gives 36. Plus 2 is 38. This is me adapting the perfect square to get the imperfect square. Next, x squared minus 12x plus 10. That is an imperfect square. But I can adapt the perfect square x minus 6 all squared to get that. Now you might be able to see what the adapting factor here is. But if not, what we can always do is think, well, this, when I square this, is going to give me a 36 that I don't want. I only want 10. So if I subtract the 36, that's going to get rid of the 36, and then add 10, well, the minus 36 plus 10 is minus 26. And so minus 26 is the adapting factor. Again, just to re-emphasize this point, the minus 6 times x is minus 6x. And we have 2 of them, so that's where the minus 12x comes from. The minus 6 squared is 36. And the 36 take away the 26 is the 10. X squared minus 12x minus 2. The perfect square that goes with this is x minus 6 all squared. I don't want the 36, so I'm going to take that away. And I do want to have a minus 2, so I'm going to put a minus 2 there. The minus 36 minus 2 is minus 38. And again, just to re-emphasize this point one final time, the minus 6 squared would give 36. The 36 subtract the 38 gives the minus 2. So the minus 38 factor is correct. So this is the process of completing the square. I'm adapting a perfect square to get these imperfect squares. Next, the perfect square that goes along with x squared plus 10x is x plus 5. But that would give me a 25 when I do the 5 squared, and I don't want 25. So I'm going to subtract that. I do want to have a plus 30. The minus 25 plus 30 is 5. So I've completed the square. I have adapted the perfect square by adding 5 to get the imperfect square. Again, just to repeat, the 5 squared is 25. The plus 5 gives me the 30. Next, the perfect square that goes with x squared minus 14x is x minus 7 all squared. But that gives me a 49 that I don't want. I only want 29. The minus 49 plus 29 is minus 20. The minus 7 squared is 49. 49 minus 20 is 29. The perfect square that goes with x squared minus 8x is x minus 4 all squared. This would give me a 16 that I don't want, so I'm going to subtract the 16. I do want to have the minus 3. Minus 16 minus 3 is minus 19. Minus 4 squared is 16. The 16 minus the 19 is the minus 3, so that works. And the last example of these type, the x squared minus 6x, the perfect square that goes along with that is x minus 3 all squared. This would give me a plus 9 that I don't want, so I'm going to subtract that. And actually, I don't want to have any number on the end there, so I'm just going to leave it as minus 9. Because the minus 3 squared would give a plus 9. The 9 minus 9 will give me the 0 on the end, which is what I want. So just to repeat, these are me adapting these perfect squares to get these imperfect squares. This is me completing the square. This one is a little bit trickier because notice we've got a coefficient of the x squared. So the first thing I'm going to do is I'm going to factorise 2 outside. So I'm going to factorise a 2 at the front. Now notice I'm using square brackets here. These square brackets are really important. Square brackets are super important for this. The only way students make mistakes with these questions is they don't use square brackets. The reason I'm using square brackets is because I'm going to actually have 2 sets of brackets in this question. The first set of brackets is when I'm factorising the 2 outside. The second set of brackets in a minute will be when I'm completing the square. So, first, let me factorise the 2 out. So I'll have an x squared, I'll have a minus 3x, and then I've got an 11 over 2 here. So, just to be super clear, the 2x squared, the 2 lots of the minus 3x, and the 2 lots of the 11 over 2. Right, now that I've factorised the 2 outside, I'm now going to complete the square on the middle bit. So I'm going to complete the square on this. The perfect square that goes with x squared minus 3x is x minus 3 over 2 squared. Don't use decimals. I know some people will look at this and think, oh, well, half of that's 1.5. But then we're going to have to square that 1.5, which is tricky to square decimals. It's easy to square fractions. When I square 3 over 2, I get 9 over 4 that I don't want. So I'm going to subtract that 9 over 4 plus the 11 over 2. So let me just, before I carry on, let me just re-emphasise the point. I need square brackets and I need the curly brackets. It's really important to have both. Right, let's continue because I can simplify this. The minus 9 over 4 plus 11 over 2, or common denominator, the 11 over 2 is the same thing as 22 over 4. Just times in top and bottom by 2. Now I've got a common denominator of 4, so therefore I can do minus 9 plus 22, which is 13. Right, I've now completed the square on the inside of these square brackets. So my last job is I'm going to multiply both this by 2 and this by 2. So I'll have 2 lots of the curly brackets, 2 lots of the x minus 3 over 2 squared, and 2 lots of the 13 over 4, which is 13 over 2. And this is my completed the square of this. Right, let's now talk about why we would want to do this. Well, there's 2 reasons. The first one is to find maximum or minimum values, or to be able to prove that a quadratic is either always positive or always negative, or always above a certain value or below a certain value. So let me explain how we can do that. I've already completed the square here on the x squared plus 6x minus 16. And I've got x plus 3 all squared minus 25. Now, this is a perfect square. It's a square number. So I know for a fact this is always positive. A square number is always positive. It cannot be negative. This is always greater than or equal to 0. It could possibly be equal to 0 if x was minus 3. If I put a minus 3 here, then on the inside I'd have minus 3 plus 3. That would be 0, and 0 squared is 0. So this could possibly equal 0, but that's the smallest it could possibly be. Therefore, when I subtract 25 from that, that means the smallest this could possibly be is minus 25. So the minimum value of this quadratic is minus 25 when x is minus 3. That is the turning point of this quadratic. So just to repeat that one more time. Because the perfect square is always greater than or equal to 0, I know it's always positive. It cannot be less than that. Therefore, I know the smallest that this can possibly be is the minus 25 on the end. That will happen when x is minus 3, because that is where the perfect square would be 0. So that's the minimum that this quadratic could be, minus 25. It has to be bigger than that or equal to that. Let's see how we can then use that to sketch this quadratic. We already know its turning point is at minus 3, minus 25. The next thing I need to know is the roots of this quadratic, which is where it intercepts on the x-axis, which is where y equals 0. So if I were to substitute 0 in instead of y here, I could say 0 equals x squared plus 6x minus 16. I can factorise now to solve this. And I find that x is either minus 8 or 2. So those are the roots. The other thing that I'd like to know here is the y-intercept. The y-intercept is where x is 0. So if I put 0 here and here, I find that it will intercept on the y-axis at minus 16. Now, with all of this information, I can draw a little sketch now. It intercepts on the y-axis at 0, minus 16, so roughly here. Its roots are at minus 8 and positive 2. The turning point was at minus 3, minus 25, which is roughly here. And now I can draw my quadratic, going down through the roots, down to the turning point, up through the intercept there and through. The line of symmetry would be here, which is x equals minus 3, because the x-coordinate is always minus 3 on that line of symmetry. Last thing for this video is a slightly harder one. So I want to sketch y equals 3x squared plus 10x minus 8. We're going to do that by finding the turning point, the roots, and the y-intercept. Now, here's my working out for this. I've already written it down just to save a bit of time, so the video is not quite as long as it would have been. but I'll explain it. So the first thing I've done is I've factorised the 3 outside. The 3 times the x squared is 3x squared. The 3 times the 10 over 3x is the 10x. And the 3 times the minus 8 over 3 is the minus 8. So step 1, I've factorised the 3 outside. Notice the square brackets. Next, I've completed the square. So I halved the 10 over 3x. So half of the 10 over 3 is 5 over 3. I've then subtracted 5 over 3 squared. And then the minus 8 over 3 is there. Next, I combined these together. Minus 25 over 9 minus 8 over 3 is minus 49 over 9. Next, I multiplied out the square brackets. 3 times this is this. 3 times this is this. Excuse me. Now I have got it and completed the square form, I can find the turning point really easily. The x coordinate is minus 5 over 3. The y coordinate of the turning point is minus 49 over 3. Next, I found the roots by factorising the quadratic to get this. And that's going to equal 0 when x is 2/3 or when x is minus 4. And then finally I found the y-intercept, which is minus 8. Let me now draw this graph. So the y-intercept is minus 8, which is roughly here. The roots are at minus 4 and 2/3. The turning point, minus 5 over 3, roughly here. Minus 49 over 3 is down here somewhere. And now we can draw a nice smooth curve through our turning point, through the y-intercept, through the 2 roots, and we're done.